So this review video is going to be on limits and evaluating limits and other tricks and tools that you can use to evaluate a limit. And this is all going to be mostly for this unit, it's going to be analytically, which means without a graph. So the first thing you're going to see is the limit of a function. The first option that you're going to always try is to try to just evaluate f of a. Sometimes it's just a super straightforward plug a value in and you can evaluate that limit because he doesn't have any issues. When you do that, one of three things is going to happen. The first thing that could happen, which is wonderful, is you get a number, meaning you plug a number, a value into the limit, nothing odd happens at that particular place, and you get a number. So the limit as x approaches a of f of x equals f of a. It also is one of our continuity components. And for this, you're just getting a number value. If that doesn't happen, one of two other things could happen. You could get a non-zero number over a zero, or you could get a 0 over 0. If you get a non-zero number over 0, like 5 over 0, then that means that there's a vertical asymptote at x equals a, which is what you're evaluating your limit at. So what you're going to say is the limit as x approaches a of f of x does not exist because f of x is headed towards either infinity or negative infinity. Now, sometimes I have seen them not have does not exist as an option because if the function is headed to infinity or to negative infinity on both sides of that asymptote, then you would say that the limit is approaching infinity or negative infinity. But if on one side of the asymptote it's headed to infinity and on the other side it's headed to negative infinity, then the limit does not exist. The third situation you can get is you could get a 0 over 0. And if that happens, it's called indeterminate form. And you need to say or state that that is an indeterminate form. Now, for at the bottom where it says AP exam tip, this is going to be our first AP exam tip. You are never going to write equals 0 over 0. When you evaluate your function or your limit and you get a 0 over 0, you're never going to use this. Instead, you're going to say, or you're going to write that. So it's sort of like this produces a 0 over 0, but you're never going to use equals 0 over 0. And we're going to talk about more specifics on that when we get to L-Hop's rule. So, indeterminate form, if that happens, you can factor and cancel and reevaluate the limit. So you can factor and cancel some things and reevaluate your limit, and usually that's all it takes. You could also use some trig identities. Turning tangent into sine over cosine, seeing one of your Pythagorean identities, something like that to help maneuver and get the section of the problem that's causing a 0 over 0 to get it out, to cancel it out. The third method is using the definition of a derivative. And this is when it was before you knew what a derivative was. Right after we did limits, we talked about how the limit as h approaches 0 of f of x minus, of f of x plus h minus f of x over h. If you can see that it fits that form, then you know that it's just the definition of a derivative. So you can completely forget the limit and just go take the derivative and then plug in your value. Another method you can use when you're doing an analytical limit, which means you're using algebra, is you can always refer to the graph or a table. And this is going to bring us down to our second exam tip. A lot of graphs we know, but the graphs that you need to make sure that you know are absolute value of x over x and sine of x over x. This was actually a limit rule that we just memorized. This one, if you'll pause and graph that on your calculator, you'll remember what he looks like because we used him a lot. So these two graphs kind of pop up, or these two limits kind of pop up a lot. So they are good ones to know. And then the last kind of trick is L-hop. And we'll do he gets his own video. So take a second and make sure that you kind of have this kind of organizational chart. When you're going to do a limit, the first thing you're going to do is try to just evaluate the limit, and sometimes that works. And then if it doesn't work, you're either going to get a non-zero over 0, which means you have a vertical asymptote, or you're going to get a 0 over 0, which is indeterminate form. And there are ways around that. You can factor and cancel. You got your trig identities. You can use your definition of a derivative.